In this video, I will show you how to create and design a multiplexer and a demultiplexer in a digital circuit. And how do we do it from scratch? Just using AND gates, OR gates, and NOT gates. And I will also show you how can you use the component in the Logisim software. So before we move into the multiplexer, I want to reintroduce you the three gates. That is the fundamental of everything. Now, here's what we are going to create later. But before we do that, let me show you the logics. Now, there are three gates that we have to understand: the NOT gate, the AND gate, and the OR gates. And in the previous video, I already talked about how it works when you think of it as true and false, 0 or 1. But now we have to think it in terms of programmable gates, which mean we would use the gates as a physical device to control the electrical signal. Now, the NOT gate first. In the NOT gates, let's say I have no input coming in, represented in 0 in red. If I have no input coming in, but if I make it go through a NOT gates, which is a physical device, then there will be some electrical signal coming out of it. Now, if I have an input 1, which means there is some signal coming in, represented in the green color. If I make it go through the NOT gates, then there will be no signal coming out of it. Now, that is the NOT gates, very easy to understand. Now, let's talk about the AND gates. And instead of think of it as logics, we have to think of it as electrical signal. So before we do that, let's just quickly draw a truth table for the AND gates. So I have A, B, and I have A and B. Okay, let's draw the truth table. I will have 4 combinations. So 0, 0, 1, 0, 0, 1, 1, 1. Now, what would be the output in this case? As you already know, the only time that A and B is true is that both of the condition is true. So this is the only time that it is true. Other than that, it will be false. Now, you can understand this in logic terms, as I already explained in previous video. But now let's use electrical signal to represent it. Okay, let's say I have signal coming in. Let's say this is A. There is some signal coming in. And I have no signal coming in the other input. So A and B are 2 inputs. One of them is green, which means there's some electrical signal coming in. But this B input, there's nothing coming in. So what would be the output? Is there any signal coming out of it? And the answer is we have to look at the truth table. This is 1, this is 0. So it will be 1 and 0. So 1 and 0. The output is 0. So the answer is there's no signal coming out of it. And the only times that there is some signal coming out is that both of the input is on. That is the only way that there's some signal coming out. So if B is green, then there will be some signal coming out of it. Now, how do you understand the AND gate? One way that I used to understand it is that I will treat the B input as a control signal. So let's say B is the control signal. That is something that you control to determine whether you want to forward the input from A to the output or not. So B is the one controlling it. If B is 1, which means B is on, then whatever I have in A will be coming out of the output. Now, you can testify it by think about it. So this is 1 right now. This is on, which means everything from A will go to the output. Now, if it is both on, then of course this is on. But what happens if A is off? Okay, so let's say A is off, so there's no signal coming out, and there will be no signal coming out either. So that is true in that case. Now let's say B is off. Let's say B is off, so there's no signal coming in. And remember that we are treating the B input as a control signal, so we control the B to determine whether we want to forward the A to the output or not. So let's say B is off, then no matter what is A, there will be no signal coming out. Okay, so that is a very good way to think about the AND gates, which is using 1 to determine whether you want to forward the other input to the output or not. The B will decide whether we will forward the A to the output. Now, the other way I normally think about the AND gates is that whenever I have multiple conditions, multiple scenario, and I want to make sure that all of the condition is true, then I want the output to be on, or I want some signal to coming out of it, then I will think of the AND gates. Because the only time the output of the AND gate is 1 or is on is that when all of the signal is on. Right now I have 2 input to the AND gate, but later on you can use multiple input for the AND gate. It can have multiple input, not just A and B. And it works in a similar way. The only time the output is 1 is that all of the input is on. Now that is a good way to think about the AND gates. Now let's talk about the OR gates. Let's draw the truth table for the OR gates. So this is A or B. Okay, I will just quickly do it. As you know, in an OR logics, if 1 is true, then the whole thing will be true. So if you can see the 1 in it, then the output will be 1. The output will be 1. Otherwise, it will be false. So now let's think of it as electrical signal. If there is some input, if there's input coming from the A input, and there's no input coming from the B. Now my question for you is there any input coming out of it? And to answer that question, you need to look at the truth table, this one, and you see that this one is on, which means this is 1, this is 0, 1, 0, the output is 1. So there is some signal coming out of it. Okay, that's how it works. And if both of them is off, so let's say this is red, then no output will be coming out. Now, when do I think of the OR gates? If I have multiple conditions and I just want to check if one of them is correct, then there will be some signal coming out of it. There will be some output. The output will be on. Then I will think of the OR gates. Now, let's talk about the multiplexer. So what is a multiplexer? First of all, multiplexer. And people normally use MUX for it. So in many software you can see the MUX, and MUX stands for multiplexer. And this is an actual physical device. So this is a device. And the purpose of a MUX is to control which input will be forward to the output. So let's say this is a MUX. Okay, so I have a MUX in here. This is called a MUX. And in this MUX, I will have multiple input coming in. So I'll have 4 input lines. This is called input line, so I call it I0, I1, I2, and I3. This one I call input line. This one is called input line. And I will also have control line. Okay, this is called the control line. Okay, control line. And I will have the output. In a mux, you can use the control line. So the control line is what you can control. So you control the control line to determine which of the input will be forward to the output. What I mean by forward is that if this one is 0, then will be 0. If this is 1 and I forward I0 to the output, this one will be copied over and it will be 1. Another way to think of it is that by changing the control line, let's say you can imagine there's some wire inside of the device that connect to it. So this is when you set it to 0, 0. Now if you set it to 0, 1, 0, 1, then there will be a line coming from I1 to the output. Now let's say you change it to 1, 0. This is what happened inside the mux. You have a connection between I2 and the output. So whatever you have for I2, it will be copied over to the output. Now if the control line is 1, 1, then I will copy I3 to the output, which means if it is 1, 1, then there's a wire that connect from I3 to the output. And you see that I use some number in the control line. So let's say I have 0, 0. These two number 0 is called the select bits. This one is called select bits. And because I have 4 input, so I have 4 input lines, I0 to I3, I have to use 2 select bits to control these 4 inputs. And this is where the binary things comes in. 0, 0, if you put it together, 0, 0 in binary is 0 in decimal. If you have 0, 1, the binary number 0, 1, this is 1 in decimal. If I have 1, 0, it is 2 in decimal. And if I have 1, 1, this is number 3 in decimal. So I have 2 select bits, and you can change this to 0, 0, or you can change it to 0, 1, 1, 0, 1, 1. So 2-bit, you can change it. And the value correspond to it is the control line, is the input line that you are selecting. And the design I have right here is called a 4-to-1 mux. So the name of it is 4-to-1 mux because I have 4 input. That's why we call it 4-to-1. Other than 4-to-1 mux, you have a 2-to-1 mux, which means you only have 2 input. You have an 8-to-1 mux, which means you have 8 input. So you have multiple lines coming in. And the number of the select bits will determine how many inputs you have. Or you can say it determines how many input you can control. So let's say I have 3 input bits, which means instead of 0, 0, it can be, okay, let's say I have 3 select bits. It can be 0, 0, 0. Let's do it this way. 0, 0, 0, like this. And then I can keep going. 1, 0, 0, which represent the input 4, all the way to 1, 1, 1. And 1, 1, 1 is 7. So it controls the input 7. So as you can see, if I have n select bits, okay, if I have n select bits, n is a number, then I will have 2 to the power of n input that I can control. Now the question that you may ask is that why do we need to use a mux to connect from 1 to the output or this one to the output? Why don't we just connect the wire to the output? And the answer is it's not an efficient way to do the selections, because let's say you have 1100 and 1024 input. Now you have to connect, you have 1024 different wires you have to determine, like which one you want to forward to the output. In that case, 1024 input. If you use a mux to decide which one you want to forward to the output, you only need 10 bits for it. You only need 10 select bits for it, because 2 to the power of 10 equal to 1024. So by only controlling 10 bits, you can determine which input out of the 1024 input bits will be forwarded to the output. So that is a very efficient way to control things and select things. Okay, now that we understand what is a mux, then let's do that in Logisim. So in Logisim, a quick way to do a mux, I will do it the quick way first. The quick way to do it is you will click on plexer. Okay, you select plexer, and then you select multiplexer. Okay, so you click it, and then you drag it here. Okay, so this one is a multiplexer. And when you click on the multiplexer, you can see these properties tabs. So this one is the property of the multiplexer that you are selecting. And you can see that we have select bits. Okay, select bits is the one that I have introduced you before. If you have the only thing you want to care about right now is just the select bits. The select bit is 1, which means you have one select bit. There will be 1 bit in the control line, and there will be 2 to the power of 1 input lines. So if you have 1 bit, 1 select bit, there will be 2 input, as you can see in here, 2 input. If I change that to, okay, click on it again. Make sure you click on it so that you can see the properties. If I change this one to 2, I change the select bit to 2, what happened? If I change that to 2, I want you to keep an eye on this, keep an eye on the input. Okay, now I press enter. Okay, you can see that instead of having 2 input, now I have 4 different input lines, just like the 4-to-1 mux that I described before. Okay, so that's the input line. Now let's change it to, okay, this is a mux. This is the input lines. This is the control lines. And this is where the output will be coming out. Now let's change it back to 1 select bit. Let's start from the simple one first. Change to 1, press enter. Now you see that there are 2 input. So I will need to create some input for it. I'll click on the wiring. Click on the wiring and I select the pin. Okay, there are 2 pins in here. Copy it. And then I connect to the input. Make sure that you connect it correctly. Okay, connect to the input. Now there will be 1 output. So for the output, I will use an LED light. So you scroll down to the input and output. Expand it. Click on LED. Okay, make sure you connect to the LED. Okay, now this is the bit, the control line. This is 1 bit. So I will just use the pin, or you can copy this one over. Okay, I'll use the pin, put it here. You can connect to it, or what you can do, I normally do is I will click on this pin. Oops, sorry. What I normally do is I will click on this pin, click on it, and I look at the properties, and you see the facing. It's facing east right now. That's why you see it in here. But I want it to face upward. So what I do is I'll click on the facing and I will choose north. Okay, as you can see, it's facing north. Okay, I'll connect to it, make it look nice. Okay, now I have a 2-to-1 mux. And in a 2-to-1 mux, I can use this select line to control the input. So let's say this is 0, and 0 in binary is 0, which means if this is 0, then I'm forwarding the first input to the output. Right now it's 0. The output is 0. Okay, I click on this icon so that I can toggle the pin. If I toggle the pin, yes, you can see that the output is on right now. So that is correct. And if I turn it off, it's off. Turn it on. And this one doesn't matter how I do it because I set this one to 0. It only forward the first one and it will ignore everything else. Okay, now if I change that to 1, 1 in binary is 1, so it is controlling this pin. And now if I toggle it, it will copy it over. The value of this pin will be copied over to the output. Turn it off, it's off again. Turn it on, it's on again. And no matter how I change the first one, it will not change the output because the select bit, the control line or the select bit, is set to 1 right now. Okay, so that is an example of a 2-to-1 mux. Okay, I'll click on the letter A. And then I will say that this is 2-to-1 mux. And you can put something in here so that you remember it. Select line. Select line. This is I0 and this is I1. That's called the label. Okay, I will change to the cursor so that I can move it around. Okay, move it around. 2-to-1 mux. I0, I1, and this is the output. Now that is a 2-to-1 mux. Let's create a 4-to-1 mux. Okay, I'll do it again. I can copy the mux, or what I can do is I can scroll down. Okay, scroll down to the plexer. Okay, plexer, this is multiplexer. This one, I click on it so that I can change the property. The only thing you should care about is select bit. Change the select bit to 2. Okay, so I will have 2 to the power of 2 input, which means I will have 4 input. Now I will repeat it by creating a bunch of pin. Okay, just a bunch of pin. Okay, that's, yep, another one. Okay, now I create the select line. Okay, select line. Okay, so when I click on select line, as you can see that we have an error, incompatible with, and the reason is, if you look at the one I showed you before, this select control line, if I have 4 input in a 4-to-1 mux, then I will need to use 2 bits, 2 select bits. Okay, so how do you change it to 2 select bits? You click on, okay, you make sure you change it to the cursor so that you can change the property. And you click on this pin. Okay, I click on it to open up the property. And you see that there is data bit. You change the data bit to 2. Okay, I change that to 2. You press enter. Now the error goes away, and you can see that there are two pin or 2 number that we can control. And I just create an output for it. This one is a 4-to-1 mux. Now let's test it. If I want to test it, I need to click on this icon. Okay, right now it's 0, 0, and 0, 0 in binary is 0, so it's controlling the first one. So if I change that to turn that on, you can see that the output is copied over. Turn it on and off again. Yep, it's controlling that one. Now if I click on the number itself, okay, there are 2 things you can click on. These 2 0 is what you can click on to change it. So now I change the first select bit to 1. Now I want you to guess which one am I controlling. And the way that you do it is convert this one into decimal. So 1, 0 is 3, 0, 1, 2. Okay, 1, 1, 0 is 2 in decimal. So 0, 1, 2. It is controlling the third one. Okay, so the third one get copied over. So no matter how I change the previous one, the other one doesn't change. It only forwards the third input. Now if I change that to 1, 1, it's turning off because 1, 1 will control the last bit, will forward the last input. Okay, that's how it works. Just forward it over. Okay, now this is a 4-to-1 mux. Let's go to the interesting part, which is recreating this one by using just logic gates. Okay, now let's create that just using logic gates. So let's create the 2-to-1 mux first, because that's easier. Okay, so what components I have, I will copy over. So I have two input, I0 and I1, I'll copy it over. I will have an output, which I have to eventually control. And then I have the select line that I have over here. Okay, so this is the thing that I need to create. I need to create something in between that will function exactly similar as this component. Okay, let's think about it. When the select line is 0, okay, when the select line is 0, that means I'm forwarding the first input, I0, to the output. Okay, when it is 0, I need to forward the first one to the output, which means if I turn I0 to 1, then the output should be on right now. Okay, so how do I do it? So there are two things. There are two variables in here that is in the equations. The first one is I0. The second one is select lines. These two things will control the output. Okay, so what options you have when you have two things? You can use an AND gate or you can use an OR gate. Which one do you use? Okay, which condition are we checking? We are checking if this one have to be on, this one have to be off. So you are checking two conditions, and you are making sure that two condition is true. So when you want to check two conditions and make sure that both of them is true, then you use an AND gate. Okay, now let's do an AND gate. We'll do more example and then you will get it. You use an AND gate. So AND gates, how do you do that? You can scroll it here, and then you can go to memory, no, arithmetic, no, gates. Yes, you scroll to gates. So you can click on gates and you can select AND gates. Or what you can do is you can select this icon. This is an AND gate. This is a NOT gate. This is an OR gate. Okay, so there are two ways you can do it. Let's say I click on AND gate and then I put it here. It works similar if you click on the icon on top, this one. It will also open it. Okay, now what is coming in the AND gates? Think about the option you are checking. You are checking if this one is on. So this is on, then I'll connect that to the first input of the AND gates. What is the condition of the select line? Okay, let's revise it. When it is 0, then it will need to forward the output. It will need to forward the input. So the select line will need to go through a NOT gate. Okay, go through a NOT gate before you go to here, and then connect it to the output. Okay, why do I need to make it go through a NOT gate? It is because when you go through a NOT gate and this one is 0, then it will be on when it goes through the NOT gate. So this thing is on, so this is true, and this is true also when you turn it on. the output will be on. And it goes to the first part of the video where I talk about treating this one as a control for the first input. So if you want to forward this one to the output, then you would use an input as a control for it. That's what I was talking about in the first part of the video. Okay, so that is how you create. That's how you create the first pin. Now let's look at the second one. Okay, how does the second one works? The second one is when the select line is 1, then we can copy over the input one, the I1. Okay, that's how you do it. And it works similar way as I talk about in the first part of the video, which you have to use an AND gate again when you want to forward something to the output. Okay, so let's create an AND gate again. Okay, let's create an AND gate. And this one will go to the first input. Now, do I make this one go through a NOT gate and then connect it here? Or what do I do? And the answer is, you don't have to make it go through a NOT gate because you are checking when the select line is 1, then you forward this. Which means you just connect it right away to the input. Now, let's test it by creating an LED lights here. Okay, let's test it. Turn it on. Okay, now it's forward. Now it's getting forward over. Okay, now how do I combine these two input so that it works in conjunction together? I need to connect this one. Sorry, I need to combine this one to one LED lights. And what gates I'm gonna do that? Okay, let's think about it. How do I do this? If I want to combine these things, I would use an OR gates for it. Okay, why is that? OR gate. Let's click on the OR gates. Drag it over. Why do I use an OR gate? It is because in an OR gate, just one thing to be on, then there will be some output. So if this is on, we don't care about the other one. If one of them is on, the output will be on. That's why we want to use an OR gate. When we want to select, then we use an OR gate. Okay, now we want to test everything together. Select line. Okay, 1 and 1. Turn on this one. Turn on this one. Okay, now the output is both on. Turn it off. It's working. Turn on the first one. It doesn't change, which is good. Now if I turn the select line off and turn on the first one, yes, it's on. Turn off the first one, it's off. If I turn the second one, it doesn't change, so it's good. It's just forwarding the first one and it disregards all other input. Okay, so that is what you have to do for a 2-to-1. I will create a 4-to-1 mux just by using these gates. And in the labs exercise, you will create the 8-to-1 mux. But now I will do this one together with you. I will copy over the component. That I know we're gonna have, which is 4 input pin. This is what we will have. I will have the select line. So instead of having the select line like this, I can use 2 pin to simulate it. Okay, I'll change the direction, make it facing up. So now these 2 pin will work similar to this one. I need to use this special one because there's only one input to the mux if I use a component in the software. But if I create something by myself, I can just use 2 separate pin for it. So now 0, 0 correspond to 0, 0. Then if I have 0, 1, this is 0, 1. If I have 1, 1, that correspond to 1, 1 over here. Okay. What else I have? I have the LED lights. Okay, so now my job is to create something in between that will make it work similar to this. Okay, just doing it one by one. It's very simple. Okay, now I will work on the first pin. Okay, how do I work on the first pin? This is 0, 0. Okay, 0, 0 means 0, so it will forward the first pin. Okay, how do I do this? What I will do is I will use an AND gate, and then I connect these two select line to it. And if I just doing this, the output will be 0. But what I want is I want to make the output to be 1, so that if I combine everything together, the output will be 1. What I am combining is I'm combining this one, first input, with the 2 select bits to generate the output I want. So I want to use this in conjunction with these 2 to generate the output I want. So in my mind, I will have to use some AND gates that combine this to this to this, and then use some NOT gates to make sure I convert the 0 into 1. So for this, I will need to make it go through a NOT gate. This one goes through a NOT gate. This one will also going through a NOT gate. Okay, why do I use that? It is because I want to make sure that when this is 0, 0, I will have some signal coming out of it. So I'll get some signal come out, and then I will combine it with the input from this one to the output. That's how I do the first pin. So right now 0, 0. Let's test that to see whether I can forward the first one. Yes, I can do that. Okay, so why do I come up with this design? That is all the way back to the first part of the video where I talk about when you have an AND gate. When you want to forward something to the output, then you will need to use an AND gate. And this part of the AND gate, this part, will control whether you want to forward the first one or not. If this is on, this part is on, then we will forward this one to the output. So in my mind, I will need to use an AND gate to combine it with this input, and then I need to do something that will have a signal coming in. And this signal is controlled by these 2 select bits. Okay, now you apply the same logics to the other bits. Okay, I'll drag it here. Let's do the other bits. I'll do a few more examples. Okay, how do I control this bit? I will control it by making this 0, 1. 0, 1 will control this one. So it will control the second bit. Okay, that is 0, 1. Why 0, 1? Okay, I'm just counting in binary. This is 0, this is 1, 2, and this is 3. I'm just counting in binary. I increase it in binary. Okay, so again, 0, 1 will control the second input, which means this will need to be 0, 1. Okay, I'll fix this. I'll keep it as 0, 1. Now I'll do something in the middle. So that it works with 0 and 1. Okay, what I'm gonna do is when it is 0 and 1, I will need to get some signal coming out so that I can combine it with an AND gate. Yep, I will need to get signal coming out to an AND gate, and then I need to make sure that this would need to be on. Okay, so the scenario will be like this: 0, 1. If I turn this one on, there will be some output coming out. so I need to force this one into 1, and I will do that by doing something over here. Okay, so now I hope you can do it. Now this one we need to go through a NOT gate to make it 1, and this one doesn't have to go through a NOT gate. We just keep it like that because that's already 1. Now I put it in some NOT gates for this one. Yep, you can connect straight to this. And that's it. If I test it again, you can see that the input is on right now. So if I turn it off, it will change it. If I change the other one, it doesn't affect. So that is good. So now, how do I combine these two input? I apply the same logics I've done before. I can use an OR gates for it. I can use an OR gates. Okay, so I hope by now you should be able to do the rest of it. Let me do some other example. Okay, now I will work on the third bit, this one. Okay, I'll work on the third one. If this is on, and how do I control this third bit? What would be the select bit? It will have to be 1 and 0. So when it is 1 and 0, it will forward this. Okay, so the way I do this, it just repeat the patterns. Change that to an AND gate. Connect it here, and then connect it here. Okay, now which one will have to go through a NOT gate? This one we need to go through a NOT gate because it is 0 right now. So I'll go to a NOT gate, and then this one, it doesn't go through a NOT gate, just connect to it. And now you can if you wanted to do it, if you want to combine it with these things, what you have to do is you have to create an OR gate, and then this one will go to the input, this one will go to another input, just like that. But then there's another way to do it, an easy way to do it, which is increasing the bit for the OR gates. So click on the OR gates, click on this one, look at the number of input, the property of the OR gates, change the number of input from 2 to 4. 2 to 4. Okay, change that to 4. Okay, so now you see that we have 4 different input. Now you can just put everything to it. Okay, put it here. Remember, you cannot combine it like this. It's gonna have some error. You need to separate it. Okay, let's go here. This one goes here, and there will be some output coming out of it. If I have an OR gate with 4 different input, if one of them is true, then the other one will be true. Okay, that is this one. I'll create the last one just to finish the work that I started. Yep, this connect here. Need to use an AND gate. Make sure this connection is on. And what is the select bit? If I want to control this input, it will have to be 1 and 1. Okay, so when it is 1 and 1, I don't have to make it go through any NOT gates. Just connect it straight away, like that. Okay, so now this one on, I can connect it to here. So now I finish it. After you create this one, you should test it with the 4-to-1 Mux to make sure it works in a similar way. And there is another way to do it quicker. which you see that in here, there are 2 AND gates. There are 2 AND gates here, 2 AND gates here, 2 AND gates here. What you can do is you can just create an AND gate like this. Let's say I want to replace this part with just 1 AND gate. Replace this with 1 AND gate. I'll click on the AND gate and I change the number of input from 2 to 3. Okay, so now it has 3 input. And what you can do is you can replace this part like this. Again, you connect everything to this AND gate. And I'll do a few more examples. I'll copy this. Okay, now I can delete this, delete this, delete this. You keep the OR gates like this. Oops. Connect it here. That's another way you can do it, which is much easier. Yep, that works similar. If you want to test it, just think about the bit that will control this one. It will be 1 and 0. Yep, so now it controls it. Similarly, you can change this thing. Delete this, delete this, delete this, delete all of these. Change that to here. Like that. This one here. This one to the second input. And then the last one. Like that. Yep. That's how you do it. Test it one more time. When it's 0, 0, shoot forward the first one. Yep. That is a 4-to-1 mux if you would do it by yourself, just using the gates, the fundamental gates, instead of the components. Now in the labs exercise, you will do this thing for an 8-to-1 mux, but I hope you can get the ideas and you can do it with an 8-to-1 mux. If you want to make it an 8-to-1 mux, what you want to do is you will want to create another pin. You create another pin, and then you create 4 other inputs. Okay, now I have explained the multiplexer. Let's talk about the demultiplexer. So demultiplexer is the opposite of multiplexer. In a multiplexer, you have multiple input, and you control some input lines. You control some select line to determine which input you want to forward to the output. The demultiplexer will be the opposite. You also have a bunch of select lines, but that select line will control which output will be turning on. So what I mean by that is, instead of doing the whiteboard, let's just do it right here. Okay, so this is a 4-to-1 mux. Let's say I want to create a 4-to-1 demux. We call it demux or demultiplexer. So in a demux, you can use the component here. So you see plexer and you see demultiplexer. You click on it, drag it here. You click on demux, and then you change the select bit to 2. So there are 2 select bits. Okay, now what I can do is I can copy this one over. This would be the select line. Remember that if you want to create that again, you click the pin, you click on the pin, and you change the data bit to 2. Yep, that's how you create it. You connect that to this one. This will be the select line. Now you always have one input like this, and that's one normally is on. And you will have 8 different input. Okay, so, sorry, not 8, 4 different input. 1, 2, 3, and 4. Like this. Okay, so in a demux, you control which output will be on. So if it is 0, 0, then this would be 0. So this will be on because that is on right now. So it's forward to the first one. Now if I change that to 1, 0, 1 in binary is 1, so it turn on the second one. If I change that to 1, 0, it turn on the other one, turn on this one, it will be on. Now that is a demux. That's basically what a demux is. There's a way you can connect a mux to a demux, which is connect these together. Okay, just connect these together. Now you have connected the mux to a demux, and the purpose of this is that you can choose which one you want to forward. Now let's say I want to forward I1 to output 3. Okay, so where is I1? This is I0, this is I1, input 1, this is output 0, output 0, this is output 1, this is output 2, and this is output 3. Okay, I'll write some more and I will change the position to make it look better. Okay, make it look a little bit better, not too messy. Yep, like that. Okay, so now if the task is to connect I1 to O3, how do you do it? So you do it step by step. First of all, you need to control this thing. Okay, so I1 is which one? I1 is this one. So now if this is on and I want to connect I1 to O3, which means O3 over here, I have to do whatever I need to do something with the select bits, both of them, so that this one is on. So let's see how would I do it. I need to do it step by step. First, I need to control the select bit of the multiplexer so that this connection is on. So to do that, what is I1? I1 is here, and I1 would be 0, 1. Okay, so 0, 1 will make this connection turn on. Now O3, okay, so right now it's on already, but O3 will be 1, 1. Yep, like that. So if I change this task to connect I1 to O2, how would you do that? I1 to O2, then O2 is over here. O2 is over here. So what is O2? O2 is 1, 0. I have connect I1 to O3. Last example, I2 to O2. Then I2 will be here, and I need to change the select bit to 1, 0. Okay, that's how you do it. And the last thing that I will do for this video, it's quite long, but I will break the video down into multiple sections, is how can you do this? How can you do the demux with just the logic gates, just like this? So similar concept, you will copy whatever components you think you will have, copy it over. And then you have 2 select bit. Okay, I'll copy these 2 select bit. Okay, I have 2 select bit. 2 select bit, and then I have 1 input, which is always 1. Okay, you can actually use a constant for this one, constant. Okay, now if it is 0, 0, I want to turn on the first one. So how would I do it? I think by now you should be able to do it. If I want to do it, I will make it go through an AND gate, and then I make it go through. By now we are advanced right now, so we're going to change that to 3 because we know how it works. Change that to 3. Okay, connect that to a NOT gate to turn it on. This one would also need to go through a NOT gate, so that is on. Okay, who turned this one off? Okay, this one should be on. Okay, I really want to make it look nice, so connect it here, and then connect it to the output. Yep, so now it works. This would be that's how you create the multiplexer. And you do similar things for O1, O2, and O3. And you don't need to do any other OR gates. We're gonna keep these things. We're gonna keep these things. Keep these O1, O2, O3. And we don't create any more input. There's only one input. So I'll do another thing, another one, and then I will let you do the rest. And I hope that, okay, number of input will be 3. Okay, what would be this? It will be 0, 1. 0, 1 will control the O1. So when it is 0, 1, which one will have to go through a NOT gate? This part will go through a NOT gate. This part doesn't have to. And this one will connect to the input. That one connect to the O1. Okay, that's how you do it. And then you repeat the patterns. You repeat the patterns and then you can do it. Now, if you want to create this thing, if you want to connect this part with this whole design, then you simply remove this output and then you connect it together. You connect, you put two things together side by side and you connect it. Just like how I connect the Mux to a Demux. That's how you connect the Mux to a Demux. Okay, so it's a pretty long video, I know, but I will break this one down into multiple sections and you can watch which one you want. Okay, so I hope this video is helpful. This is very fundamental. In the future, we can create many programs just by using these gates.